Let's continue with our coverage of the rational class. I've added 5 more functions to the class. These functions are operator overloading functions. I've overloaded the operators addition, subtraction, multiplication, division, and a less than operator. The operators, the implementation of these operators utilizes the functions add, subtract, multiply, divide, and compare to that we have worked on earlier. All of these operators basically apply the arithmetic operations, addition, subtraction, multiplication, division, to two rational objects, and the result will be a rational object as well, except the operator less than, which returns a Boolean data type. Let's test these operators in a program. In particular, if you look at line 14, now that we have overloaded the operator addition, I can actually use that operator and add two rational objects. So R1 plus R2 will add the two rational objects and return a rational object as well, which I'm saving it in RA, and then display RA by calling the function toString. So we can run this program right now. And R1, R2, and R3 are displayed, and then RA, which is the sum of R1 and R2, gives us 10 over 33. Now, I can, since we have overloaded the operator subtraction, I can subtract these two rational objects and then look at the result. The result of subtraction of R1 minus R2 is 34 divided by 33. Similarly, I can multiply them, I can divide them. Here is the multiplication as well. So all those operators now can be applied to the rational object, and that's the key part of this particular discussion. So R1 times R2 is negative 8 over 33. And we can also use the comparison. I can have C out, for example, and then bool alpha. Let me apply one of these IO manip commands, alpha, and then apply and see if R1 is less than R2. So end line. Now that we have overloaded the operator less than, I can apply it to two rational objects, and the return type will be Boolean. If R1 is less than R2, then true will be returned, and if that is not the case, a false will be returned. And I've used the bool alpha so that instead of 0, 1, we'll actually see the text true or false. So let's run this as well and make sure that the operator less than works. There is the result of the operator comparison. So R1 is 2/3. Is R1 less than R2, which is negative 4 over 11? That's certainly false. I can change this to R2. Is R2 less than R1? That should return true for us. I'll test it. And in this case, true. R2 is less than R1. So similarly, we can overload the operator greater than or the operator equal to as well.